I disagree with Einstein's idea that time and length change with speed, and here is why. Einstein's special relativity equations may be based on a false premise derived from a thought experiment using a light clock and two observers. Einstein used the Pythagorean theorem to conclude that time must be the variable in order to solve the illusion of light appearing to travel faster from one observer than another. Time dilation and length contraction were the results of Einstein's equations. If the original premise is flawed, then everything else that follows must be wrong. I created a diagram explaining this image illusion delay and fed it to ChatGBT. Here's what happened. I uploaded my diagram and typed in the following: explain how time dilation may not exist because Einstein did not factor in the time delay for light to travel to the stationary observer from the observer in motion in special relativity equations. ChatGBT replied, below is a clear, physics-accurate explanation of why light travel delay does not eliminate or negate Einstein's time dilation, and why special relativity already accounts for the issue shown in your diagram. I'll also connect your drawing to what the actual special relativity equations describe. Short answer: Einstein did not forget to include light travel delay. He purposely separates what clocks actually read in their own locations, proper time, from what a distant observer sees by looking at delayed light signals. These are not the same thing. Special relativity's time dilation equation is about the actual physical elapsed time on a moving clock, not about the time you visually observe due to signal delay. Light travel delay is accounted for separately and must be subtracted out before comparing clock rates. Special relativity equations already do this. So light travel delay does not explain time dilation, and removing the delay does not remove the effect. Your sketch shows a moving observer with multiple clocks, M0, M1, M2, etc. A stationary observer receiving light signals from those clocks. Light rays traveling down to the stationary observer. Many little eyes marking what moment the stationary observer sees on the moving clocks. This is a very good conceptual visualization of a known distinction. The stationary observer sees the moving clocks out of sync because of light delay versus the stationary observer calculates the moving clocks actually run slow even after correcting for light delay, actual time dilation. Your diagram captures the first effect, but not the second, where the misunderstanding happens. It is completely natural to think, maybe the clocks only look slow because their signals take longer to arrive. But Einstein addressed this explicitly in 1905. He distinguishes apparent time, what you visually see due to light delay. This is affected by different distances, changing Doppler shifts, coordinate time, what you deduce after correcting for signal delay. This is the time used in the Lorentz transformations. Proper time, the time the clock itself measures locally. This is the actual physical tick rate of the moving clock. Time dilation refers to proper time, not apparent time. Why light delay cannot explain special relativity time dilation. Let's walk it through cleanly. Light delay is symmetric. If light travel delay were the cause of time dilation, then a stationary observer sees a moving clock slow. A moving observer sees the stationary clock slow by the same amount. But they do not simply see the same slowdown. They see different Doppler shifts depending on approach or recession. Special relativity time dilation, however, is symmetric and not dependent on direction. So light delay alone cannot cause special relativity time dilation. Time dilation remains after removing all light travel delay. A standard special relativity procedure eliminates light delay. Observers exchange light signals. Each subtracts the signal travel time using the known speed of light. They compute what the other clock actually read at the moment the signal was sent. After this correction, the asymmetry from distance disappears. The Doppler effect disappears. Time dilation remains. This is exactly what Einstein does in the derivation of the Lorentz transformation. Moving clocks accumulate less proper time. This is not visual, it's physical. Examples where light delay is removed entirely: particle lifetime experiments. Muons created in the upper atmosphere live approximately 2 milliseconds at rest. Yet they reach the ground because their proper time is dilated. No observer is seeing them in flight. The muons actually age slower, atomic clocks on airplanes. Haefel-Keating. Clocks flown around Earth physically disagree with clocks on the ground, even after being brought back together. No signal delay involved. They're compared side by side afterward. GPS satellite clocks. They must be pre-offset because they physically run fast. General relativity and slow. Special relativity. Again, this is not optical delay. These experiments compare clocks locally, with no light travel delay at all. How to interpret your diagram correctly. Your drawing beautifully shows. The stationary observer sees signals from the moving clock at times t0, t1, t2, etc. The moving observer sees different delays for each emitted signal. Light paths vary with distance. Observed, apparent, time is different from emitted time. This is the visual Doppler layer of special relativity. But special relativity time dilation refers to the proper time layer, i.e., what the clocks themselves measure along their world lines. To extract proper time from your diagram, the stationary observer would note arrival time of each signal. Subtract travel time, distance divided by c, deduce the emission time. After doing that correction, the stationary observer will find the moving clock ticked fewer times between events than the stationary clock. This is true even if both clocks are later placed next to each other. Your diagram includes only the raw observed signals but not the light time correction. Once corrected, special relativity prediction remains. Final conclusion: Einstein did not forget light travel delay. He explicitly removes it before deriving time dilation. Time dilation is not a visual illusion, not caused by signal delay. Verified by physical clock comparisons. Independent of line-of-sight distance or Doppler shift. A consequence of the Lorentz transformation and invariance of proper time. Your diagram is excellent. It shows the apparent relativity of timing. But after correcting for delay, time dilation still exists.